Hi, I'm following along with Paul McCord's Raspberry Pi Pico W lessons and number 64. And this is actually my second video on uh, this lesson. The first one was about uh, the fact that his classes actually could only blink his LEDs consecutively, like 10 blinks and on the red and 10 blinks on the green. And so they didn't blink at the same time. So I came up with a video on how I would approach a different way of doing it. And of course, my friend and fellow coder Charlotte promptly did a video showing how to do it better. So she's always the better coder and better ideas than I have. And but my way worked, but her way worked better. And we were having this is my video down here, as you can see, and we were having a nice little uh, video or comment chat about ways of doing it. And of course, here I can show you. Charlotte, you're right. YouTube is not your friend. Here I brought up the video today, and it says I have 8 comments, but it's blocked our whole thread out of it. So just to prove that they are available, or YouTube says they're available, I can go to um my YouTube studio, and here's that whole thread where we're talking about, and I'm telling them about async IO and stuff like that. So I'm uh, I definitely, for some reason, YouTube is doing funny things with the comments on their videos these days. I've noticed it before that sometimes they don't show up, and I'm certainly not moderating my video, my uh, comments or anything. And you have this held for review thing. I don't know what that's about, but there's never been any of them in there. So I have no idea why they didn't show up, Charlotte. Okay, back to why we're doing it. So I mentioned async IO in the comments here, and um, I didn't really want to get into stuff that Paul hasn't covered, but uh, it's a good topic, and I didn't know a whole lot about it, so I took a little bit of a deep dive into it today. I knew it was available, but I hadn't really uh, played around with it, and I still have only scratched the surface with it. But I did find a good video. Uh, if anybody hasn't found it yet, the DigiKey has a ton of videos on their YouTube channel, and a lot of them have to do with microcontrollers and a lot of different other things. That very interesting channel if you want to check it out sometime. I'll leave a link to this particular video in my comments so you can find it. But in your YouTube searches in the search bar, a lot of times some of their stuff will come up for if you're searching electronics parts and stuff like that, it'll come up, with a video that they've done on it. Anyhow, so I watched this video. It's 25-minute video, but 2 years, it's 2 years old. You can see it's 2 years old, but it's still pretty relevant. I think most of the stuff in there is still pretty relevant. Um, but yeah, it worked out well for what I wanted to look at it for. Anyhow, so along with this video, I also, of course, check out the MicroPython documentation and searching for the async IO, and you got all this documentation here, along with some sample code that you can use, and it's got a lot of functions and stuff that you can use. I've played around. I'm not showing it, but I've played around with the events. They seem to work all right. I haven't done this thread safe stuff yet, and haven't worried about the locks or the streaming or this for I think servers and stuff like that down there. I haven't really looked at that. So Async IO is uh, in that video from DigiKey has a good review on what exactly it is and how it's different than threads and things like that. So it's a it's a good tool to have in your tool chest. Um, it's not perfect because anything in your program that's async IO has to, or everything that's in the program has to be what they call awaitable or compatible with the async IO. And that can cause some problems, probably if you're doing, some display stuff or other things that might not be what they call awaitable and everything. But for for general use, for getting things done at the same time, blinking multiple leads and reading buttons and everything. Um, so far, it looks like it's a pretty good thing, but it does have its limitations. Oh, yeah, I have to mention that a big limitation is that you can't use your input. You can't get shell input because it'll block your. It's not awaitable or whatever they call it, so you can't use input. We do have two threads on the, or two cores on the Pico and Pico W chips. And I think you could probably use that second thread to get input if you wanted to work with that. But I may or may not do that in the future, look into it. But I think there probably is a way to use that second thread to be able to use inputs. I have a video a while back, I can't remember which one it was, where I showed that you can use NeoPixels and use the second thread for input to pick which NeoPixel uh, pattern you want to put up. So, there is a way that you can get input and not interrupt your main thread. So, that's something to for the future, though. Anyhow, there's two things about this example code that they show here that I had to think about for a second. The first thing is that they're referring to like a LED just by the pin and pin number. We do that in our code where we say red lead equals pin, and we give it a pin number, and we call it an output or an input or whatever. And but we do that, but I I didn't realize, and I should have, that the pin is an object as well as anything else, and we're just giving it the name red lead or yellow lead or whatever. So it's still a pin object. So they're just using the pin objects directly and putting the pin numbers inside of it. And so they use that and thought, well, that's kind of different. And so in my first code, I was just kind of doing my own thing, following this example code, but making it my own like I normally do. So we can get into that code. And the second thing to notice is that they're calling that pin, and like I say, they're not defining it, and they're not calling output on it, pin.out, like we have to do, or what we do on our uh, normal pins. But from my Arduino days, and I think it's just a way that microcontrollers are set up, that by default they are output, so you don't have to call that out on these pins. um, that it's automatic, that's the default state for them to be output. So you don't, unless no reason to call that output. But it's good to have it so that you know what you're doing. That okay, you're blinking the leads, you want it to be an output. but it's actually an optional parameter that you put in there that they're showing that it's not needed. And so here's a couple things. I always learn a lot when I'm looking at documentation, and that was like an off the wall thing that I learned. So let's get to my code. This video is already going to be really long. So anyhow, so I've the first time I did, like I said, I used the pin up here and refer to the objects as pins. So instead of saying red lead dot on or lead dot on, we're just using pin and then lead pin, whichever number. And as you can see down here, we're just passing in numbers is all we're passing in. So the best thing to do to see how my description of how this works is not going to be very complete. Just go watch the DigiKey video. It'll make a lot more sense than I do. So anyhow, but basically you set up it's a scheduler and you just set up these tasks and they run. And like these tasks are in a while true loop. So you're doing this blink. So it's a while true. So this task is going to run forever, but you're going to run the second test with a different number, and it's also going to run forever. And because we can await these, they don't block this sleep milliseconds, async IO sleep milliseconds. If you await them, then it goes to this, and then it says, okay, I'm just waiting. I'm going to let something else do their job. So when we create two tasks, it does the first task and might blink it, turn it on, and then I'll say, oh, I'm waiting. I'll go see who else needs me to do some task, and then does the other thing. And like I said, um, these are tasks that are set up, and it's just a way, and you have to have these, and everything in here that you go to has to be an awaitable object. And so in the same way in all these are awaitable. These two are going to call an awaitable. And then to finish, you don't want the program to close. So you just have to have a while true. And all you're doing here is using the awaitable sleep, and you're just waiting them 1,000 milliseconds and then going back and just waiting again. So this is just a way to keep your program alive. You can't put like pass down here because that's not awaitable. So you actually have to call in an awaitable object and get that done. So like I said, this is I, I'm not even going to show this working. This works just fine, but I don't have to show it working. But like I said, we're using the pin and the pin numbers, and that, like I say, it was a good process for me to learn. Okay, you don't always have to have at declaring them, but I think this will make a lot more sense to people that are following Paul's lesson, where you actually set up a red lead and a yellow lead, and you're calling this pin, and you're giving it the pin number, and you're saying pin dot out. So this is like I say, it adds a couple lines of code, but it's a little bit more readable. Another thing that you might find if you go to play with these, if you noticed on the let's minimize this, that they're importing async IO. And I think that my Picos have been had MicroPython put on them since we started Paul's lesson 64 weeks ago. So they probably changed this, but now or the MicroPython that we have on our Pico or that I had 64 weeks ago, it's actually called async IO from micro usync IO. And I just said import it as that because I started out with just copying and pasting the code that they had, and it didn't work. I said, oh, and but the guy from DigiKey talks about he just keeps it as UASyncio, and like you say, his is 2 years old, his video, so I guess that's why. But I just wanted to keep it as Asyncio, so I just changed the name a little bit so I can use that. Anyhow, so like I said, we're from machine. You gotta get for your pins and everything. But and as you can see, Paul's in lesson 64 is talking about classes, and I'm certainly you could probably use async IO in classes. Two things as I think that's definitely a next step up, and I don't not comfortable enough to try to put them in classes. And the second thing is you really don't need them in classes because you're actually creating these tasks, and probably in the background they are actually uh, uh, they're class objects, I'm sure, in the background. But just the fact that they're that you can call as many, you could call each one of for all the LEDs on your thing, you could probably just create a task for each one and blink it a different color and everything, and or blink it at a different speed. So like you said, I'm passing in the lead number here, which is the red lead, or LED, which is our red lead, which is this object here. So it all goes back to it. That's why we could use the pin in the past, on that last code. And then we're having an on time and an off time. And it's as simple as, because this function is running one time for the red lead, and we're calling it the same function for the yellow lead, but they're running at the same time concurrently, um, just, taking the time they need to do what they want to do. And so they're, you know, but they, don't block each other like a normal program does. So I will show this one running. So let's go ahead and run this one. And oh, you can see that the yellow lead is blinking quite fast and the red lead is blinking a little slower. And I don't have anything I got a blue LED hooked up, but it's not blinking at all quite yet. So that's the basics of it. And you get that working and it just fine. So let's go ahead and stop this one. And then in my previous uh, program or code, I had a way of doing it with blinking a certain number of times and then stopping. So I came up with uh, a, where I added, I did it all in one function or in the other one, but I figured, I think it'd be easier just to do it in two different functions. I call one blink and I call one blink T for times, number of times that we're going to blink it. I just coming up with a name of it. And so, like I said, this code is exactly the same, and the first two are exactly the same. But like I said, I call an extra lead LED and call it blue LED. And it's actually, I call the blink T on it. And so I'm passing not only the LED, but in the on time and off time, but also the number of blinks. And basically, instead of a while true, so it blinks all the time, while blinks are greater than 0, I just do this. And then after it goes through and turns it on and waits and turns it on and waits, and then I reduce the number of blinks to 1. So when number of blinks gets down to 0, this is going to stop. So it's not going to run, but how many ever times you tell it to run. And then it just kind of just, instead of this while just drops out, and function just ends, and that doesn't seem to bother the program here that it ends. So it's not a problem. It doesn't seem to be a problem at all. And everything else is pretty much the same down here, but you'll see that the blue LED is going to blink 10 times when we do it. Run this, and then it'll stop. But the other two LEDs just keep doing their thing. So let's go ahead and run this. And then you can see two, I don't know, three, maybe four blinks on the blue, five blinks, six, seven. It does 10, but I might have missed one along the way. So we'll see when it stops. Should get there you go. So the blue LED stops and it doesn't break the program or anything. And we just keep blinking the other ones. So I'm going to go ahead and stop this one. One more program that we're going to look over is on that DigiKey. He gets into how you can do the same thing of waiting for a button. So we can do that. So this is, and I'm not actually using thread in here. I think I was planning on using thread and I didn't do it. So anyhow, so this is actually, okay, so I actually, okay, I didn't realize this, but I actually using this for the buttons, and I'm actually just using the number. So this goes back all the way to that first program where we're using the pin here. I forgot that I hadn't changed that one. I went back and changed the two LED. So this one is, like I said, you're just passing in the pin that you want. So it works exactly the same way, except we're not defining them as red, yellow, and blue or whatever. We're just using the numbers. And um, yeah, I forgot I did that. So anyhow, it still works. So so anyhow, we've added this button one here to it. So we it's still, and then we have to call it as a task, and it's a button that waits for the value to be pressed. And the way back in when we were doing buttons on the Pico, somebody come up with this idea that they could do uh, less than, that you, instead of doing if button is this way and this button is that way, or this value is that way, that all you have to do is create this less than or greater than equal to previous state. So what it means is that we want this to fall out of this when the state goes from high to low. Remember, we're using this, setting up this pin as a pull up. So the normal state of that pin for input is going to be high until we press it, and then it shorts it to ground, and then it's going to go low. So a button press is going to be when the old state is high and the new state is low. So we are doing the opposite of this. So as long as button state is greater than or equal to previous state, then the button hasn't been pressed and it hasn't been released. And this, like I say, this takes into account a release. This will only trigger one time because it has to wait for the button to be released before it is true again. And all we're doing is if it's not in the press state, then we're just going to read the button value again. We're going to do this 25 milliseconds only await, and then we're going to go back up into the while loop. And until we get to the state where the button goes from high to low. Then it's going to drop out of this while loop, and it's going to do that task of blink T, which is the number of times, and it's going to do it 10 times. So every time this button gets pressed, it's going to run this task up here, and it's going to do it on, this is the, my blue LED is on pin 13, which is what we got set up out there. And then just this next weight down here is that after it goes and does that, we don't want it to read it too fast because of getting the messed up the from the button press. We're going to wait 25 milliseconds just to stabilize the pin, and then go back up and start the while true up here all over again. So it's going to start waiting for the button press again. And but like I said, that's how it works. So, and everything else, like I said, we're just calling all these as tasks, and they're running all concurrently. All these tasks are running concurrently, and so in 39 lines of code, we can do all that, and we can show it running. So when we start this, because the button hasn't pressed, the blue LED is not going to run at all. So let's go ahead and show this. So this is the yellow lead is blinking fast. The red LED is blinking a little bit slower, but I got this one red button up here just wired up with this big old long wire. So when I press that, it's blue is gonna start the 10 blinks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and now it's not going to blink anymore. Now this is because everything's in a loop and it's all awaiting and all async, and we can go ahead and do it again, and it'll do the 10 blinks again. Now I wondered what happens if you press the button ahead of time. So if you press the button ahead of time, all it does is it calls that function again, and that 10, it's going to redo the 10 blinks. So if you do it in the middle, it's going to be 10 blinks from the time you press the button. So, but so anyhow, you got all these LEDs doing their own thing, and buttons reading. And like I say, you're you're not waiting on the button to do, your buttons are responsive and everything like that. So this video is going way too long, but I just wanted to show a different way of doing it. But like I said, this is definitely a different way of programming. You're creating these I might not have mentioned, but the only thing, these are all async functions, and so the only thing that is actually running everything is you're calling this asyncio.run main, and it's like creates this loop that does this main loop thing here, and everything in, like I say, everything in this main has to be awaitable, they call it. And so anything you call, like if you called a function that asks for input, it would just block everything, because function, it has to be awaitable. I haven't tried that. I know that's what they say in the documentation and the everything, but whether everything starts back up after you would enter your input or not, I don't know, but it would definitely throw your program off. So anyhow, that's all I got for today. Thanks for watching. Thanks, Paul, for all you do. And Charlotte, I know you'll probably have some good comments on here, and I hope they show up.